last class, I asked you to uh, try out how to sort a an array of strings. Anyone solve that problem? Ananya. Okay. So Ananya, would you like to share your code and show it on the screen so that we will discuss who else did it? We will look at couple of codes, and that would be the primary thing that we will be doing in today's. Let's do screen share first, Ananya, and then after that we can send the code. Who else did it apart from Ananya? Let me give the permission for you to share. Yeah, now you can share. And you can unmute yourself, Ananya, as you explain your code. So
Am I audible?
nice. You want to explain? Okay, okay.
Am I
I see
audible?
what you are trying to.
Right.
Okay. So you have, you can handle maximum 10 names.
Yes, sir.
I am not able to hear Ananya. Just want to
Oh,
check. Maybe some problem in my. Just give me a minute. I will. Now I think I might be able to. Can you speak now, Ananya?
now am I audible?
For me, I'm not able to hear anything at all. A change in my hearing Zoom settings. Can you speak?
Am I audible now?
How about now? Can you try now?
Am I audible now?
Can't hear. Okay, we'll. All right, so we will manage without Ananya's voice, although it would be great if we can hear her explanation of her code.
Okay,
So,
shall
okay,
I?
Ananya, so you can, when you want something, no, to tell something, you can type in the editor so that we can see.
Oh,
So the first question is, you are trying to read the input from line number 7 to 10. And when you see double slash, then you will, okay, great. So what Ananya is doing, so on line number 7 to 10, Ananya is doing is reading, and on line number 24 to 27, she is printing, and on line number 12 to 21, she is sorting the code, and the particular approach she is taking to solve is what is called as a uh, bubble sort. Yeah. So she is using a bubble sort approach to solve it. Great. Okay. Nice. So Ananya, you send me your code to me. Yeah. So it's good. So you can send your code to me through email. I will use it from my machine and discuss it. Anyone else wants to share your code? Show it on the screen. Shantanu says that he uses hashing. Okay, I don't know. Who else did it? That's all. Come on, guys. You should should try these problems. That's how you learn. All right, then I assume.
Sir, I can, if you want.
Okay, let's see your
I
code, how
changed
it
it. I
looks like.
changed it.
Okay, go ahead, Shantanu.
Okay.
Thank you, Ananya. It's very, very well written, short piece of code. Very much, very nice. Very nice. Good. Okay, you are reading 5 strings. Go down. Compare string names. String compare. Go down. Nice. Nice. Okay. Okay. Yeah. So this code is very similar to Ananya's code. So except you are using getters to read, and the number of strings that you are reading is fixed number of strings. If you go to the input, so you read 10 strings, right? So I is equal to 0 to I less than 10. So you read 10 strings. Great. Okay. Thank you, Shantam. Nice. I understood. Very nice. Hey, but can you show your code again? There's one small issue. In the inner loop, that is, it's not right, na? There's an outer loop and inner loop. In the inner loop, when you use the same for j is equal to 1 to 10, it should not work. So something amiss. So you need to, because in the bubble sort, you bubble up I will discuss the bubble sort in a moment. You bubble up the largest element and then you try to sort the rest of the n-1 elements. But well, it will still work, but unnecessarily you, yeah, I think the code will still work, but you'll unnecessarily end up making comparisons maybe. Yeah, that's true. It will still work, but yeah, you do more work than necessary. Because when you try to bubble up a different number, you will be, once you hit the, no, like for example, anyway, I will send me this code. I will explain the problem to other students who see this thing. But it will work in terms of correctness. It is good. I don't see any issue. Send me through email, okay? Not on the chat.
Okay, sir.
Great. Who else did this problem? Solve this problem? Did anyone try selection sort approach for this? Yes, no. Okay then. Yeah. So let's get going. We will start now. I will share my screen. Okay. Nice. Great. So can you see my screen, guys? Okay. So first, there are few things I would like you to, this is what is called as a bubble sort code, bubble sort approach. We didn't see bubble sort before. So let me quickly explain what bubble sort is. Um, so in bubble sort, let's say you have a list of numbers, 2, 3, -1, 4, 5, or let me use, yeah, what's the big deal? Yeah, let me use 0. So this is the initial list of numbers. So in the, you can see, so what we do is, in the first shot, in the first iteration, let's say, for example, for k is equal to 0, you can see, 12, for k is equal to 0, there is an inner loop. You set k is equal to 0, and then I will mute you. So what happens is, in the inner loop, as L progresses, so you compare 2 and 3. So 3 is greater than 2. So you don't do anything. So the list remains the same. It's not going to change. And then after that, you compare 3 and -1, and 3 is greater than -1. So what happens is, you swap these two, you get 4, 0. And then you compare 3 and 4. 4 is greater than 3, so you don't do any swap. The list remains the same. And then you compare 4 and 0. So 4 is greater than 0. So what happens is, this becomes this. So this is one, when k is equal to 0, that is one iteration of the outer loop, is in one iteration of the outer loop, you bubble up the biggest element here. So this element's position is fixed. So this element's position is fixed. In the next iteration, you just focus your attention when k is equal to 1. So I'll write here k is equal to 1. When k is equal to 1, you fix the position of 4 as it is. You are not going to. Hello, can you hear me? There is some problem. You can hear me, right? Yeah. You can see the screen also, I hope. Yeah. So here when k is equal to 1, you kind of leave the last element and you work on these elements 2, -1, 3, 0, 4. And you are not going to touch the element 4, and you repeat the same process. So you compare 2 and -1. So -1, 2 is greater than -1. So you have this, and 4 remains the same. Let's not bother about 4. And now you compare 2 and 3. 3 is greater than 2. So 2, 3, it remains the same. Now you compare 3 and 0. So 3 is greater than 0. So you have 0, 3, 4. So now what happens is the position of 3 and 4 are fixed. So you focus on -1 to 0 and you iterate. The same process happens. So in when k is equal to 1, you leave the last element and you do a bubble sort on the rest of the rest. And when k is equal to 2, in the next iteration, you leave the last two elements and you sort the rest of the prefix code. This is how the sorting bubble sort algorithm works. Are you all with me on the basic bubble sort algorithm? Yes, no? Right? So I hope, yeah, great. So here, now if you see this code, what from line number 7 to you can see on line number 5, you are declaring an array of 2D array. So it can, since the number of rows is 10, it can hold maximum of 10 names. And since the number of columns is 100, the size of a name, the maximum length of the name is 99, because you need one more character to hold the null character, one more position or one more byte to hold the null character. And in this do while loop, you keep scanning the input, and when you see this uh, two backslashes in the input, then that's when you terminate the input. So you can see Ananya is using two functions. One is a string copy function and other is a string compare and string copy function. And these two, if you want to use these two functions, you have to include string.h file. You have to include the string.h file. All right. And yeah. So, and then finally here she is just printing the last, at the end on line 24 to 27, she is printing the input. She is printing the sorted list of names. So there is one convention, it seems to be there, that I would be happy to use actually, rather than I'm clearing this. Let's focus our attention on input. I would be more happy to use this, because like ours is a 2D array of the data structure that we are using is a 2D array of characters. So this is row 0, this is row 1, this is row 2, so on and so forth. So this is row I. And then, so each of these, it's an array of every row, it's an array. Every row, it's a array. This is column 0, column 1, column 2, so on and so forth. So in order for us to be able to read into the ith row, we should give the base address of the ith row. And in order to give the base address of the ith row, we can use this particular approach, that is you give address of a of I0 because a of I0 is the first element or the 0th element in the ith row. So you put that ampersand. But apparently this is also working. So this is what I didn't know actually before, because yeah, so even if you use just a of I indicating that it is an ith row, it seems to be working. But this particular idea we didn't discuss before in the class. I have to check on that, how the C compiler interprets A of I. So, but if you see on line number 10, if you want to read into the ith row, you can use A of I, the address of A of I0, because that gives the base address of the row I. Are you with me on this one, on the reading part? And what will string compare do? So string compare, I need to explain what this string compare does. So, so string compare, if you, let me check this code. So this is the man page. So whenever you get a doubt on some function, you should look at the man pages. Okay, so string compare. So what it does is it takes pointers for two strings, pointer for two strings, and if s1 is less than s2, then it returns some value which is less than 0. And if s1 is equal to s2, when I say s1 is equal to s2, that means then this is then it returns some value, then it returns 0. And if s1 if s1 is greater than s2, then it returns a value which is greater than 0. So what does this S1 less than S2 means? Like, for example, if you have something like this, this is like dictionary order. So if you take two names, let's say, no, Rama and Kishore, okay? So if you take two names, Rama and Kishore, uh, so which one comes before in the dictionary? Rama and Kishore? I'm just use both are capital letters. So Kishore occurs before Rama. So what happens is, so since Kishore is, how do we check whether Kishore is less than Rama or not? So yeah, let's say the first name is this. Yeah, I want to use this. Yeah. So Rama, Kishore. So what happens is you compare this R and K, and since R occurs later than K, that means Kishore occurs earlier in the dictionary. So what this means is, what this implies is, Kishore is, so let's say S1 is equal to Rama and S2 is equal to Kishore, then what will be the return value? Some value greater than 0. Yeah, because Rama is greater than Kishore, the return value will be 0. So in this case, this will be the return value. So since Rama is greater than Kishore, the return value is this. Are you with me here? And if both the names are Rama, then the return value will be equal to 0. And on the contrary, let's say, uh, so the other case is, can you give me a case? Let's say the two names are Abhinav and so let's say you are comparing Abhinav and Bharat. So when you are comparing Abhinav and Bharat, so you compare A and B. So A occurs earlier. So because of that, Abhinav occurs earlier in the dictionary. So Abhinav is less than 2. So the return value from the string compare is some value less than 0. So good question. So there are some, let's say if it is Abhinav and Arush, what happens? What will be returned if it is Abhinav and Arush? What will be the return value? So here A and A are matching with each other, and no, B and R will be compared. So since B occurs earlier than R, that is string S1 is less than S2. So because of that, the value will be less than, return will be less than 0. So because of that, the value that will be returned will be less than 0. And now there is a question about capital case letters and small case letters. What is the ASCII value of, let's say we compare this, okay, Abhinav versus Abhinav. What will be the return value? Abhinav versus Abhinav. Whose ASCII, what will be the, is the ASCII value of A greater or the ASCII value of small a, capital A of, is the ASCII value of capital A greater or the ASCII value of small a greater? Okay. So the ASCII value of A is 65 apparently, and the ASCII value of small a is 97. So because of that, Abhinav, the return value will be less than 0. Does this make sense, guys? Are you all with me? Okay. Nice. So now let's go to the program. Let's go to the program. And so that's what is happening here. You can see, and the third idea that is used is how do you swap strings? How do you swap uh, so here in the inner loop here, what is being done is you are comparing two adjacent elements on line 15, and if the element L minus 1 or the string L minus 1 and if the string L minus 1 is greater than string L, then we want to swap them. Let's call this as, let's say you extend this a bit further. So let's call this as, let's make this L, L minus 1 and L. So you are comparing these, the string in row L minus 1 and string in row L. And so let's say if the string in row L minus 1 is bigger than the string in row L, then we want to swap them. How do we swap them? So in order to swap them, you create an array, temporary array, temp, an array temp. It's an array. It has, it's an array of characters. So what you do is, the first thing that you do is you copy this using the string. So using the string copy function on line number 17, there is a string copy function. So using the string copy function, you copy the string from L minus 1 in the row L minus 1 to the temp array. And then after that, what do? You copy the string L that is present in row L to row L minus 1. This is using the line number 18. And finally, what do? You copy the string that is present in temp to L. And this you do using what is there on line number 90. Does this make sense? This string swap, how this string swap is happening here? Are you all with me? Yes or no? Okay. So this is how you can do sorting of strings using bubble sort algorithm. See, guys, so there is the thing about handling uppercase letters, lowercase letters. What if there is a space? There are few issues. Those are all peripheral issues. They can be taken care of. But the core idea is this, that how do you compare strings? How do we, kind of swap two strings? How do you read names into a 2D array of characters? And that the main idea behind the bubble sort code. So these are the main ideas that you should be looking for in this program. It is not necessary for the both strings to have the same length. No, it's not necessary. Like for example, if you want to compare Rama with Ramakrishna, so what happens is the comparison happens between this R, A, M, A, and then after that this string gets terminated, but this string has more characters, so this string comes later in the dictionary. Yeah, so Rama is less. That's true. Are you all with me on this whole program? Does this make sense? So just give me a minute. I will be back. Just give me 1 minute. I'll be back and we will look at couple of more codes. There are a couple of more codes from section B1. They are very interesting. So we will go through those codes also and then conclude today's lecture. Okay, just give me a minute. I'll be back. Okay, I'm back. So let's look at more couple of more programs. I will show you. Yeah. So this is the code written by your one of your friends, Abhijit, I guess, from section B1. So here he is doing a bubble sort code, and the only difference is no, this loop is the loop on line number 13, the loop on line number 15. They correspond to the bubble sort code. And what he is doing on, yeah, I kind of deleted part of his code, my bad. So he just checks, yeah. So instead of, let me do this, yeah. So he wrote this string compare code unwittingly by on his own. If S1 is greater, yeah. So here what is being done is, so in the for loop from 21 to 29, he keeps he's comparing row I with row I plus 1, and the character j starts from j is equal to 0, j plus 1, j is equal to, so maybe in order to make this code slightly more clean, we can make this j is equal to 0 here, and we don't need this s1 is equal to 0 and s2 is equal to 0. They are not necessary, they don't serve any purpose. Yeah, so this is the code. So he keeps comparing the character by character, and as long as they are equal, you continue. If S1 is equal to S2, you continue, you don't do anything. But if S1 is not equal to S2, then at that time you break from the loop and you compare whether S1 is greater than S2 or not. If S1 is greater than S2, then that means no, the string on row I is occurring is greater than the string on in row I plus 1. Greater means it occurs lexicographically later than the string that is present in row I plus 1. Does this logic make sense to you? The logic from line 18 to line 33. So this is the original code written by him, and what I did in the class is I said, okay, it's all great. So you are doing stuff from the scratch. You just comment this out, and instead you can use this approach. You can just kind of say yeah. So this is instead of that for loop, we just replaced it with a string compare operation. Explain line 20. Yeah? So actually this here, the line 20, he is unnecessarily making it into complex thing. He is just typecasting it to integer. You don't need to typecast it to integer. The ASCII value associated with the character position present at the jth position, it will be assigned to S1 and S2. So you don't need to cast it to an integer. It's not necessary. Does this make sense, Keshav? You just need to assign it. You don't need int and all. There is no casting required at all here. Okay, so what is S1 and S2? S1 and S2 are integers. So what happens is the ASCII value associated with A or whatever that character, it gets assigned to S1 and S2. So there is no information loss. So it's all good. So there is nothing to worry about here. What is stored in S of ij is the ASCII value associated with the character there. That ASCII value will be assigned to the variables S1 and S2 respectively on lines 20 and 21. Any more questions on this code? Are you all good? Make sense? Okay, so now let's look at one more code, very nice code that is written, that is on selection sort. This is written by Narayana from section B1. There are few things that I want you to, there are few ideas that you should learn from this code. Number one, you can see the, yeah, of course, stdio.h, you need it for printf and scanf functions. and you need string.h for string compare and string copy operations. And he requires std bool.h because in this code, he is also in this program, he has written a function to search a name, to search a name. And this search underscore name function, it checks if a particular name that is given is present in the array of names. If it is present, it returns true, otherwise it returns false. So this true and false, they are not primitive data types of C, but they are there in the function in the header file stdbool.h. So because of that, he has to include stdbool.h in his program. And then he uses macros, max underscore names, max underscore length. So this is something you should use. So because in all the codes that you have seen, you have hard coded the array lengths, right? It's a bad idea. So you should use macros. So Ananya and all of you who have written the code, you should try to use macros. It makes the code more robust and more readable. In his program, he uses five functions. One is read underscore names, sort underscore names, which sorts the names, and search underscore name is the function which searches whether a given name is present in the list. Print underscore name prints all the names, and swap function. If you see in his program, he defines these functions following the main, and he uses these functions and he calls these functions in the function main. So when a function definition, when a function is defined after it is called, like for example, read underscore names is defined on line number 38, but it is called on line number 24. So when such a thing happens, it is essential to declare what is called as a function prototype at the beginning. This function prototype, so function prototype, it contains uh, what are the type of parameters that we are passing to the function. That's number one. Number two is what is the return value? What is the type of the return value from the function? That information we need to declare. This is also called as function type signature. Or function declaration. Right? So when you are defining a function after a function call or before it is, uh, uh, if a function is defined after it is called, like for example, again, just to re-emphasize, on line number 25, we are calling sort underscore names function, but it is defined later. So it is good to put the function prototype here before. If you don't put the function prototype, the compiler will give a warning because it doesn't know, hey, you are calling sort underscore names function. I don't know what sort underscore name expects and what it returns. So the compiler will not be able to do type checking. So because of that, it gives errors. It doesn't give error, it shows warnings. So like, for example, let's compile this code. Let's go to, yeah. So if you see, right now, GCC, what's this program? String sort underscore solution. So if I compile this code, there is no problem. But let's say if I kind of uh, comment out read underscore names and try to compile, then it gives a warning that read underscore names function uh, on line number 25 that you are calling, I don't know its type. I don't know its type. And it implicitly assumes the type of the read underscore names based on the parameter that is being passed. So this is not good. So we should make this declaration explicit. So we should keep the function prototype so that we don't end up making mistakes. Are you with me on this one? Yes or no? Okay. The second important idea, so here now let's look at the code for main. On line number 25, he is calling the read underscore names function. In the read underscore names function, we are passing a 2D array as a parameter. When we pass a 2D array as a parameter, we are not actually passing the 2D array as a parameter, we are passing the base address of the 2D array as a parameter. And when we are passing a 2D array as a when the function takes a 2D array as a parameter, it is essential that we specify the dimension of the second, the length of the second dimension. So in one of the classes, we kind of wrote a function to read 1D array. When we are working with 1D arrays, okay, so you just put empty square bracket. This kind of works. But when we are working with 2D arrays, we need to give the dimension of the second, the width or the length of the second dimension. So why is this necessary? Because let's say we are working with, no, in this, in 43, let's say we want to extract the address of the I comma jth location of the I comma jth element. What is the address of I comma jth element in the names array? What is the address? What is the address? Let's say names has number of rows in names is m and number of columns is n. Then what will be the address? Then the address of this will be names plus I times n plus j. This is the address of names of ij. Yes or no? Does it make sense? Are you with me? Remember, so the names is a 2D array. So this is 2D array, and it has n columns. It has n columns. So when we are in ith column, ith row and jth column, so you have to leave I rows, and the length of I rows is this is 0. So before this I, there are I rows. You have to leave I rows, and the length of I rows is n. Each row is n. So I star n plus j. That is how it works. So if you don't, so this n, the number of columns is an essential information for us to be able to access elements of the names array in the read underscore names function. So because of that, the compiler expects that we pass the dimension of the, or the width or the length of the second dimension of this 2D array. Are you all with me here on this point? Right? The second thing here is, so here he keeps reading uh, names from the file. No, the number of rows is not dynamic here. No. Then let's not worry about it otherwise. I mean, the number of rows can actually vary. Yeah. You can pass any 2D array where the column width is the same, number of columns are the same, but the number of rows can change. But memory is stored in linear format. A 2D array is also mapped into a 1D array. That's true, as a linear array of bytes. No, the problem here is in this program, the problem is somewhere here in this function. If you are using names of ij, then if you are using names of ij, then the compiler needs to compute the address of the element names of ij, and the address of the element names of ij is names of I star max underscore length th plus j. That is the address of the element names of ij. If you don't pass this max underscore length parameter here, there is no way for the compiler to figure out the address of the location names of the address of the element names of ij. So because of that we need it. Are you with me on what I have written on line 46? Okay, great. Let me comment this out. Anyway, so now, so we keep reading the elements and from the keyboard, and after you enter the list of elements, you press Control D, because Control D, when we press Control D, then end of file symbol will be returned by scanf. Or the other way is, if you are reading, if you are redirecting input from a list of the list of names from a file, then also the end of file symbol will be encountered. Sorry, I got disconnected. Can you hear me now? Yeah. Nice. Can you see the screen? Nice. So after you, there's segmentation fault. Huh? Why is there a segmentation fault? Let's see. Oh, okay, I see the problem. Let's do one thing. He is doing few more things. Yeah. So anyway, so the point here is yeah. So we are trying to look at this read underscore names function. This is very nicely written. After you enter all your names, you should press Control D, and when Control D is pressed, then scanf returns end of file symbol. you can, the way, so there is a list of names.txt in which, Narayana already has names, and this is what he used it for. And this is what he used. So when we do this dot, so then the names in that names.txt file will be supplied as input to the program. And at the end of the file, the control D symbol or end of file symbol will automatically be supplied. And because of that, what happens is this condition gets scanf returns end of file and you come out of this file. Are you all with me on the read underscore names function? There are two ways of entering the input. One is through keyboard and one is through file. When you try to enter it through a file, then the end of file symbol is automatically supplied after the whole contents of the file are supplied. And when we are trying to enter the input through the keyboard, you explicitly give the end of file symbol by pressing Ctrl D. Okay. And then, so now after you read the names, after this is what happens on line number 25, you read the names and then you call on line number 26, sort names. So now you go to line number 26. So the way he does is he tries to find the maximal name and move it to the last position. So, and what he is doing is, let's say this is what is being done. So let me write it down here. So this is your 2D array. This is your 2D array. Row 0, row 1, row 2. This is row size -1. Okay, of course, this is column 0, column 1, so on and so forth. So here what he is doing is the last row, the string or the name that is present in the last row, he considers it as the maximal element. And he copies it into a variable, into a string variable first. And then he iterates. So he keeps going down. He compares the 0th element with the 0th name with the last name. And then he compares the first name with the last name, so on and so forth. But let's say he encounters a particular name which is larger than the name that is present here, and that is what is happening. So first is smaller than the names of I, in which case he wants to do a swap. He wants to do a swap of these two. And he calls this swap by he has a swap function in which he passes the address of the address of the ith row and the address of the last row, and the swap function just swaps these two strings. You can go and see here the swap functions, it just swaps these two strings. That is how it is being done. And after this one iteration of the for loop, what happens is the maximal element will be present in the last position. The maximal element will be present in the last position. So this contains the max element, max name. So now he iterates, he recurses, the base address of the array remains the same, but the number of rows reduces by 1. So he makes the size of the array less than 1, size -1. That's all. This is how the recursive selection sort algorithm works. So this is a very nicely written code and which illustrates many nice ideas. I hope you understood this code. Did you understand the code, Narayana? Hey, sorry, guys. So for some reason, I am getting disconnected from Zoom. I am on in campus with good internet connection, but still facing some issues today. But my question is, did you all understood the selection sort code? What is happening? You want to find the max element and move the max element. So, so this is very well written. So this is the largest element. So you keep going from here. You compare this name with the largest. You compare this name with the largest. You compare the ith name with the largest. And if the ith name is larger than the largest, then you swap these two. So that is what he is trying to do. And at the end of the day, after you find the largest element, you iterate on the rest. You iterate from here to here. And the size gets reduced by 1 because no, you already figured out the largest element. That's it. Okay. So does this all mean? I hope so. Many nice, cool ideas are there in today's class. Simple but very interesting ideas. I hope you understood these ideas completely. And yeah, so let's stop today's lecture here. Saturday's lecture, Jiawul will take, and he will talk about structures. And in the Monday, in the next week class, I will discuss dynamic memory. We'll actually revisit this sorting problem, and then there are a couple of issues here. We will try to address these issues. Just 1 minute. Just give me 1 minute. I wanted to do some